Let's work through a type of example that you can see in this first part of probability and statistics. Uh, if you're a basketball player, Haley, and she's made 44 out of 50 shots for her basketball team so far this season, what's the probability that she's going to sink her next shot? Well, in this case, we know what her probability is, and this is an experimental probability. So we're going to write this down as a fraction or a decimal or a percent, and that's going to tell us what the probability of our next shot is going to be. So the math for this is we take the smaller number, 44 divided by 50, because how many shots she took, we end up getting 0.88 or 88%. So we can say that Haley's got an 88% chance of making her next shot. That's based on experimental probability. Theoretically, ball goes in or ball does not go in. There's a 50% chance of making the shot with a few other variables along the way. For argument's sake, theoretically is a 50% chance. We're going to go with our experimental data here because we know what kind of shooter she is. Okay, let's add to that problem a little bit. Let's see that Bree is also on the team. She's only taken 25 shots so far, but she scored 18 of them. What's the probability that she's going to miss the next shot? Well, it turns out there's two ways you can do this. If we remember that our probability should always add up to 100% or 1, well, we can calculate the probability that we have and then subtract that from 1, because the probability that we have is if she makes the shot. We're trying to solve if she doesn't make the shot. So if she makes a shot, it's 18 out of 25, which is 72%. 100 minus 72 gives us 28%. The other option is you can calculate how many shots she's missed just by inferring on the information you have there. If she scored 18, well, she's missed 7 of them. So 7 over 25 is 28%. So let me throw a little bit of a teaser at you here. Between Haley and Bree, who's the better player? If you have answered with anything other than it depends, then you have been influenced by subjective judgment. We don't have enough information about these two basketball players, right? I didn't even say they're on the same team, in the question, but if they were on the same team, I know I said that earlier, but if they were on the same team, maybe they play different positions. Maybe Haley's in a position to score more shots than Bree would be. Maybe Bree takes her shots from further out, right? If the basketball hoop is 2 feet away from me, I feel like I'm going to make a lot more of my shots than if I'm shooting 20 feet back. The other thing is, I haven't said which games they've played in. Maybe Bree is a stronger player, so the coach plays Bree against the harder teams, which makes it harder to make her shots. And maybe Haley's just starting out, and she plays against some of the weaker teams. There's so many variables and so many parameters that we can't quite understand the whole concept of who's better unless we take subjective judgment into account. So it exists. We could say that, hey, well, Haley's making 88% of her shots. She has to be the better player. Fine. But realize what assumptions you're making and make sure that you're aware of those assumptions. So this is your intro to probability and statistics. I'll give you some practice to try out, and then we will pick this up a little bit later in the week, most probably, if not early next week. Hope you're doing absolutely fantastically well, grade 9s. I do miss you. We will see you in the next one.